Well, hello and welcome to another episode of Undercooled. Today, we are really lucky to have a special guest that I ran into at lunch here at the TMS meeting. Isn't it great? You can go to a TMS meeting and run into all these people.
Fateful slice of pizza.
I'm going to let Tim introduce our special guest.
Yes, our humble podcast is being visited by podcast royalty today. We have none other than Taylor Sparks with us, and we're very excited to talk with him about everything from large language models to podcasting and just how we can teach students better and reach the public better when we want to communicate about material science. So Taylor, welcome to the show. We're very happy to have you here.
Pleasure to be here. This is one of my favorite meetings. It's one that I never miss, the TMS annual meeting, and it's fun to meet new people and surprisingly learn about things that I should know about, like the Undercooled podcast. I'm really excited to dive into it myself now that I know about it.
Great. Well, let's do some introductions for the audience who may not be acquainted with you. Can you just tell us where you come from, who you are, what are you doing currently? And we always want to have the origin story of how did you become a material scientist?
Absolutely. So my name's Taylor Sparks. I'm at the University of Utah. I'm a professor, so I just finally got that done. No more rungs to climb. I'm there, which feels really great. I've been there for 12 years. What's really cool about me is I'm actually teaching in the department where I was as an undergrad 20 years ago. In fact, I'm in the same office where I was a TA 20 years ago, teaching the same class. But now it's wild. It's fun. Journey to get where I am today. And why material science? How did I end up in it? I was one of these students in high school who liked all things tech. My parents bought me like an electronics kit, or I remember building a motion detector for my room so I could see if my brother was going to sneak in there. That sort of stuff was all fun to me. I loved it. I kind of thought I was headed down the medicine track until I watched a surgery video and was like, no, that's not for me. So I do a year before I'm LDS. I'm a member of the Church of Jesus Christ Latter-day Saints, and in our church, the young men go on mission. So I went down to Argentina for 2 years after high school. But in the year before doing that, I went and got all my generals done at a university. I went to Westminster College, which is like a rich kid school, but I'm not a rich kid. And so being there, I just felt super out of place. And I knew coming back from my mission after 2 years, I was going to switch probably to the University of Utah because it just made sense, cost effective, and it's a good school. But I had no idea what major I was going to do. And I had essentially done all my gen ed, so I didn't have any more time to kill. It was time to pick a major. And so I did what probably most students do, sat down with every advisor I could find, and they tell me why mechanical engineering is so great, why chem is where you ought to be, why ECE is so cool. And then I see one on the list that's material science, and it was the last one I met with. And I remember talking to the advisor, and she's like, geez, you kind of like everything, because I did. I liked physics, I liked chemistry, I like it all. And she's like, well, then you're a material scientist. And I was like, well, what even is that? She's like, it's the confluence of physics and mech-e, and you do circuit design, like all these things, they all rely on materials. And you can work on all those areas while not being stuck in one area. It was like music to my ears. I was like, I instantly knew that this was the right fit for me, at least enough for me to take the Intro to Materials course, which I took, absolutely fell in love. The concept of structure, property, processing just snapped for me, and I've never looked back.
So you went right from being an undergraduate to going to graduate school?
Yeah, great question. I was working actually at a company called Ceramatech. It's a ceramics company in Salt Lake City. It was a spinoff of the university 30 years prior. They basically did like fuel cell and related technologies in ceramics. I was working there because I was married. Weird thing about students in Utah is a lot of us are married when we're going to as undergrads. And so I was just trying to pay the bills, honestly. And it was nice that I was doing that using content that I was learning in classes. It felt like a good reinforcement way. But when I was there, I was working on what's called an SBIR grant, which is basically small amounts of money on a very short time frame to get something commercialized. It's the government incentivizing inventions. And we were working on this type of installation where my advisor, my boss at work, basically told me to add a little bit of bentonite clay, a little bit to our stuff. And it wildly improved the properties of this particular application. And I remember telling him like, whoa, like, how did you know that a little bit of clay would change it so much? And he's like, I didn't, and I don't care, and we just got to get out the door. I was just like, that was so unsatisfying for me. I remember thinking like, God, he doesn't know, he doesn't care. Like, we just want to like make a product. I was excited about the product, but I was griping about this to a guy named Raymond Cutler, who's become my lifelong mentor, a phenomenal ceramic scientist. And I tell him how frustrated I was, like, oh, Taylor, you need to go to grad school. And at the time, I'd never even entertained the notion. I didn't know if I was even competitive. I had good grades, but I didn't have any papers published because I was at a company. Nothing gets published there. Nothing did. So he was the one who told me, you ought to go. You're as good as anybody. You could go anywhere. So I did. I applied to all the top 10 schools and lucked out. Ended up getting in. Yeah, I think he was surprised. I think he told me to, not really thinking I'd get in. And I got in, and he's like, "What, you just got in?" And I told him, "Well, who should I work with?" He's like, "You just get a pick." So he helped me pick my advisor. It's just been, I owe him a lot. He was a great mentor for me.
So you went to Utah for graduate school for
No,
PhD?
I went to UC Santa Barbara, which at
Santa
the time
Barbara.
was #2 school for material science.
So who did you work for?
I worked for a guy named David Clark,
Yeah.
microscopist, TEM guy.
Yeah.
Very famous for things like intergranular phases between grains. There's this glassy layer. Anyways, that was his sort of claim to fame. And I was working with him as an experimentalist on what are called thermal barrier coatings. Your audience may know these. About the thickness of your fingernail, but they've got like a 300 degrees Celsius, reduction in the heat so that you can take these nickel superalloys to even crazier temperatures. They are critical, and I worked on them. I was interested in thermal conductivity. How do you make materials that have even lower thermal conductivity so they push that temperature ever higher? And I spent my whole PhD doing that, and a little bit of work on oxide thermoelectrics. He actually switched schools on me halfway through. He went to Harvard. Yeah,
right.
They poached his wife is really what happened. He came along as the +1. I came along as his +1. My wife came along. It was this whole chain of events. And to be honest, I loved Santa Barbara, and Harvard I also learned to love, but it was very different.
Oh, so you went with him to Harvard?
I was one of the few of the group. Most of them stay in Santa Barbara. If you've been, it's a heaven on earth sort of place. And so understandably, many students opted to stay there. He was my guy I wanted to work with. He's the reason I, fell in love with ceramics, to a far greater degree once I got to grad school. He was a good advisor. He was hard. He had high expectations, but he crafted me into a better scientist. So when he was leaving, I just had, the only way I could do it was to go with him. And I don't regret it, although it was a very different culture at Harvard than UCSB.
Yeah, absolutely. It's funny, I just gave a talk in the education symposium here, and it was about a book that I had read called Grading for Growth.
Okay.
And it's a radical, it's one of these alternative grading schemes. And the authors of the book are, one of the authors is David Clark, but it's a different David Clark.
It's not my David Clark.
No, this is a math professor at Grand Valley State in Michigan, along with Robert Talbert, who I had known, who is one of the, he wrote the original blogs on flipped teaching.
Okay.
Way back.
Okay, yeah.
And so these are real experts, but it was really funny because in my talk I said, this book is written by, Robert Talbert and David Clark, but not the David Clark all of you know.
Not the material scientist.
Right.
Well, so I never knew that I wanted to go to academia. That was never my objective. I don't know if it's a question you're leaning towards, but I never thought that was in the cards for me. So I wasn't prepping for it. But, as most graduates, even now, it's usually typically the case that we expect grad students to help be a TA for a semester, right? And I did it at Santa Barbara. And then when I went to Harvard, they made me do it again. I remember rolling my eyes and being grumpy about it. But in hindsight, that was an incredibly important experience towards my progress towards becoming a faculty. I did it for Charlie Marcus. Some people know him, physics folks. He's a pretty famous material scientist in the optics and physics world. And also for Eric Mazur, another guy who's pretty famous for pedagogy and innovations. And for the first time, Eric's famous for what's called peer instruction. Essentially, when you teach a class, you're constantly asking the students to prove it themselves in small group discussions. I'd never seen this done before. And so I was TAing for Physics 1, which I felt I knew well, but this method of teaching was radically different. And so it was interesting because I saw Eric was coaching Charlie on how to teach like this. Charlie didn't know how to do this and was a good sport to give it a try. Tried it for half the semester and ended up bailing. It was just not the right fit for his teaching style. But me as a fly on the wall as the TA, it all of a sudden opened my eyes you can just try stuff. You can just do stuff. There's nobody telling you have to teach a certain way. If you think you've got a better pedagogy, you just do it. And I loved that. Even though I don't replicate peer instruction the way that Eric maybe does or did, it was really eye-opening to me to realize that you can just try things. And as long as you have the student's interest at heart and you're not doing anything crazy, you can just do it. I learned a lot in that.
Absolutely. Eric's a very, very good friend of mine. I made 5 trips one term after he reinvented himself. He had a sabbatical and he redid the library that was up there.
Okay, yeah.
And turned that into his classroom.
Yep.
And it was all team-based, project-based learning,
Yep.
using learning catalytics, using what was then nb.mit.edu,
Okay.
NB for Nota Bene, but it kept crashing. The servers kept crashing, and I tried his technique, and his postdocs actually zoomed in with my team to develop the natural language processing
No
tool
way.
that they
That's so cool.
added to
So
NB.
ahead of its time.
Yeah, well, he did it with this guy Gary King at Harvard, and then of course Eric developed Perusal and
Yeah.
put all those elements in. So now the comments are all automatically graded. The only problem is now that ChatGPT is widely available,
Yeah.
all the students cheat,
That's right.
and so it's been very challenging. But
It needs
Eric's a
yet
very
another
good
round of
friend,
reinvention.
and I do ultra-fast laser interaction with materials.
So
just like
research-wise, you
Eric.
also know him.
But I saw Eric give his talk about peer instruction in 1996. And I was the first person on Michigan's campus to use a clicker before they were clickers.
Sure.
It was the, this wired thing with TI-83 calculator. So anyway, it's awesome that you got to work with Eric because he's a great guy and he's an amazing scientist.
It was formative for me.
Yeah. That's great. And so now what are your research areas now that you're a professor?
So I told you that my background was an experimental ceramics guy. Now I don't do that anymore. I still work in ceramics. I think they're interesting. And we do some experiments. But what I've made a name for myself is in a completely different field. I'll back up a minute. When I left David's group at Harvard, I went to Santa Barbara again for a postdoc. I worked with a guy named Ram Seshadri, who's phenomenal. And he had me working on magnetoelectrics, right? So more experimental work. And we were publishing on some thermoelectrics, magnetoelectrics at the time, and we had followed what I thought was the game that everybody played in that field is it can't be an insulator, it can't be a metal, in between is where it's at. That's where we find the best performance. And there was a family of pyrochlores, where as you go across the rare earth series, it switches metal insulator transition. So we thought maybe in the middle, we're gonna get a hit. And we didn't. We had bad materials. And trying to understand what made them bad, I was curious because thermoelectrics are complicated in that you care about both electrical and thermal transport and other factors. So we decided, let's just plot our properties and then plot other known materials and get a feel for why we did so badly. Well, that was interesting. Next thing you know, I've got my clathrates and my zinthals, my sclerudites, and my oxides, and it was just so interesting to get this bird's eye view of the field that we kept on adding more. Next thing you know, we had by hand, with like some undergrad help, scraped like hundreds of papers data, and I built this website. I remember thinking like, this is the most intense review article I've ever written. Like this is so above and beyond what most people do. And we published it. It made the cover of Chemistry Materials. I was super excited about it. There was no machine learning or even real data science there. It was just data visualization. It was a review paper that had a unique way of visualizing stuff. This gets published, and a company that had just been formed that year, Citrine Informatics, now has become an important, machine learning company in material science, really the original. They reached out to us, they saw the paper, and they're like, hey, what do you do with your data? And I remember thinking, I literally said like, what do you want the data for? I couldn't conceive what they wanted the raw data for. I was like, I built you guys a website. It's all this stuff. He's like, no, give us the data and we will teach you how to do machine learning. And I, at the time, was like, machine what? I really didn't know what that was. I had taken one coding class in my life. It was in high school, like C++.
Same.
This was like, it felt like a total waste of my time, but I was like, whatever, I can help them out, let's do it. And at the same time, I'd just gotten a job offer at the University of Utah. When I came out to the University of Utah for my interview, like most faculty, you pitch your low risk, medium risk, and high risk. My stuff that I was sure I was going to work on was more thermal barrier coatings, probably some thermoelectrics. And then I pitched as my high risk. I was like, maybe there's something to this materials plus data thing. And everyone in my department rolled their eyes and said, there's not even material science, don't do that. And fast forward 12 years, that's where the vast majority of my funding has come from. That's where my most exciting developments have taken place. That's really where we are now world leaders, is in this materials informatics space, leveraging machine learning and data science tools for all the same tasks that material scientists have tried to do for millennia, but we are using a new tool set that feels like easy mode. It feels like cheating, how effective it is compared to the old tried and true methods of materials development. So that is my area broadly. We still do some experiments, but we have a lot of cool data science tools that we both use existing as well as developing new methodologies.
Very cool. Thinking about the students in the audience for a minute, if a student is interested in going into this area, in learning more about materials informatics, what should they do to prepare? What kind of courses could they take, or
Sure.
how could a student get into this field if they think it's exciting?
Well, First off, I'm going to point you to my YouTube series on it. I teach I'm not, no one's going to say that Sparks is a humble person, but I really do think that it is like the definitive materials informatics course that you can find out there. I update it regularly. The notes are on GitHub. The entire playlist is on YouTube. I think it is your first place to go for learning about materials informatics. I start from the ground up explaining what you need to know. That said, nowadays, many departments have started to offer this. Maybe at your own school, you might have a materials informatics course. If you don't, I hope you'll check out our series. And if you want to keep learning, I would recommend that you actually take a bunch of CS courses, right? The whole point of going to grad school or college in general is to learn, not to be scared of something new and different. It's become much more approachable. Every university has realized how powerful artificial intelligence is in every field. And so they're offering courses that are approachable, even if you're not a computer scientist. So dive in, learn about it, like be curious. You might not end up going down that route, but to me, graduating in an engineering degree in the year 2025 without a basic functional understanding of machine learning and how you can use it for your discipline is just like malpractice. You should be learning how to do that. We should teach that instead of stats, instead of PDEs, instead of OChem. Like it's, in my view, more important than any of those things, even though it largely builds on them.
Yeah, I think there's a lot of truth to what you say. It was interesting in your talk today. I was waiting for you to say citrine, but you didn't mention them.
I mean, they were great. They showed us how to get in this field, but it's been 12 years. We've sort of left the nest of them helping us get started, and we are now autonomous, but they are still close friends. They've hired multiple of my former students, actually. 3 of my former students have worked or are working for them. We've collaborated on grants. They joke that they call us Fockers, friends of citrine. And I consider myself a Focker. I have a citrine shirt I often wear to conferences. So I love them. Bryce is a dear friend of mine. These are great people.
Yeah. As you know, a lot of materials programs have trouble attracting undergrads to their program. And most of the difficulty has been the rise of AI and machine learning and all of that. But I think you just pointed out something that we all know. It's better for a student to learn a trade and learn computer science at the same time. A quarter of our faculty are computer scientists.
I'm not surprised.
Right? We have 25 faculty, and 5 of them, are computer scientists, all doing machine learning. Liz Holm is our department chair. She's been doing machine learning.
She's a leader
for decades.
In image segmentation, there's nobody better.
And then we've got, Wen Hao Sun, who's
also
advisor,
really good.
at Berkeley was Gerd Cedar, and so he's doing all this, and Liang Qi is doing mechanical properties simulations, all with machine learning. So it's so embedded. And yet, tragically, we don't really even have a course for it. But then again, I think the whole notion of a course, of a textbook, is actually changing. And so we are absolutely going to put your course into our show notes. And hopefully you can help us with a bunch of links to add in.
Absolutely.
We put it in both the podcast show notes and in the YouTube show notes.
Yep.
And soon we'll be having our own YouTube channel for this podcast, so it's easier for people to find. But speaking of podcasts, you've been running probably the most popular materials podcast in the history of the world, Materialism. And maybe you can tell us a little bit about why you started it, where the name came from, and what you've been doing with it, and where you see it going in the future.
Brad, yeah. I like to joke now that it's the #1 material science podcast because there's only like one. But what makes me proud is we actually have at multiple times hit the #1 spot in the chemistry category on iTunes. And we aren't even chemists, which is really cool. We're regularly, almost always in the top 5, and we've taken the #1 spot numerous times. So we are excited because looking back to when it started, we've come a long ways. I had talked about a podcast for years. I was one of these guys who loves podcasts. I can list you like 10 of my favorite shows. Like I still listen to podcasts. I think it's a fascinating medium. I'm an auditory guy. Like I love learning. I'm one of these dudes who turns it up to 2x and can just like consume media by listening. That is my favorite version of learning. So I was looking for a material science podcast for me to listen to, and it didn't exist. There's been off and on a few here and there. Most of them I think were defunct. They were all defunct at the time that I started, so there's no active ones. But they were also not what I was looking for. Mostly it'd be they'd interview some academic who would go immediately into academies and just lose you talking about something, not realizing that, I don't know who they thought their target audience was, but it wasn't me because I was lost. And that's disappointing that you're trying to find this medium to learn from and it just wasn't there. But every other field, mechanical engineering, chemistry, like physics, these all have great accessible shows. And so I had talked for years about, I should do a podcast, I should do a podcast. I had started a YouTube channel years prior to that. And so I thought, if I'm doing the YouTube anyways, maybe I should do the podcast. And I ran into the problem that is known as analysis paralysis, basically. Like I was overthinking it so much, like what will the episodes be? What topics will I cover? How will I record it? Like, will I do interviews? Will I do like, there's so many things that you don't know which one will work that it was constantly an excuse to say, I'm still considering it. And so here I was talking about it, and there was an undergraduate, he was a freshman or a sophomore, named Andrew Falkowski. Those who listen to the podcast now know that name because he's my co-host and has been for 6 years. He was this undergrad who I was talking to about the podcast, and he's like, let's just record it. And I was like, what do you mean? He's like, let's just record it. And so he showed up in my office and plops a little 4-track janky recorder on there and 2 like really crappy mics, and we recorded an episode without any prep, without anything. You just like record an episode on steel with like winging it, and it was bad. It was like, I was like, at the end of it, it was cathartic to get that first one out of the way. It's like, okay, like we did it. And it wasn't good enough to release, I thought. But I was like, let's go back to the drawing board and actually do this proper. So the very first episode, we actually scripted, I'm embarrassed to say. Like every line, every joke, every word was written out.
No.
It was like 10 pages. It was way too long. It's to this date our most popular episode. I'm like so embarrassed because like people love this one. And I'm like, no, like we didn't know what we were doing yet. It was chock full of interesting content, but the delivery was bad. But we got that first one out of the way. I don't think anybody listened to it at first. I remember thinking like my mom and grandma might be listening, but I doubt anybody else is out there. But we posted it, and like the numbers just start climbing, and people are out there. And then we start getting, we had said like, if you want to hear an episode, shoot us an email. And people did. They started recommending tons of episodes. And so we started to refine the format. Andrew is the one who proposed the Materialism name. I didn't want to do it because I was like, that's like a philosophy about like worldly goods and like, or I don't even know. And honestly, he's like, I like it. And I was like, you know what? Let's do it. We created this entity together. We're co-owners of. It's actually a business now. We're 50-50 partners. He's now my PhD student. We've been through thick and thin. He's in a phenomenal resource. He's an undergrad who acts like an old man. He like reads a lot. He reads more than I do. He's extremely knowledgeable. He has an extremely high bar for quality that I would be much more sloppy about. And honestly, he's like, that episode wasn't good enough. We have to re-record it. And I'm like rolling my eyes, but I couldn't do it without him. Hugely grateful. And basically, we just refined it over the years. We realized that we wanted to touch on all things material science: commercialization, basic research, processing, characterization, interesting stories, you name it. And we, at first, were cycling through those in a sort of rigid fashion. Now we've loosened it up. We still touch on all those things, but we're not stuck to a rigid schedule. And 6 years later, we've refined things. We offer, the format's changed a little bit. We certainly don't do scripts anymore. We now have notes that guide the research. We found a sweet spot between doing some interviews, but not too many, because the deep dives that Andrew and I can do by doing a crap ton of research on a topic ourselves and distilling it is something that you can't get out of an interview oftentimes, because most people that you interview don't speak to their audience in a narrative format, meaning they don't tell stories that are interesting. They rely heavily on jargon, so words that your audience doesn't know. They don't know how to explain things really simply. And we've learned to do those things over 6 years of practice. And it's all led to a very popular medium that people have connected with. At a conference like this at the TMS, I've had probably 36 random people come up to me like, you're the guy. You're the materialism guy. And it's like, I'm just delighted. I joke with my wife and family that I'm like a niche, like micro celebrity. I've got a brother who's like an actual celebrity. I've got a brother who's like an actual celebrity, and I am a super niche version of that, which they give me a hard time for. But I love it because, again, I'm connecting with students. As an example, I give a lot of talks at universities. I'll go to universities to present a seminar, and the typical is that you'll meet with students for lunch before the seminar. It's very typical. I've never had a case where I go and somebody hasn't watched one of my YouTube videos, listened to the podcast, who says like, hey, I consume some of the media you create, and it's helping me know my major better. So it's been a really great reinforcement loop to have me have motivation to keep on cranking out episodes because it's a lot of work.
That's really something as a creator that is so important, is when someone can come tell you, hey, this thing that you made, it made a difference to me. Because it's so hard to just shout out into the vacuum and hope that it made a difference to someone.
Yeah, I mean, it's one thing to see the stats climbing and you're like, someone's listening, someone likes it. But it's another when they come and you put a face to a name. It made it really valuable. So we've been talking about the podcast, but my YouTube channel is probably an even bigger impact globally. The numbers are 10x, probably more. And I remember the day when I got a comment on one of my videos on some technique. And this guy, it was a kid in India, and he's like, imagine me, a poor kid in India without access to go to the university, can learn material science and engineering from a world leader for free. And I was just like, holy cow, like there's something to this. I got started on that, honestly, because I had a bunch of students on the ski team. University of Utah, 17-time national champions in the ski team. We know who we are. They do a great job. But I, for some reason, had a couple students in my class on the ski team, and they're gone for like the month of February, and it's a university excused absence. And I was like, come on, like, how am I supposed to? And they're like, you have to, it's required. So I was like, what do you want me to do? Like, I'm teaching ceramics at the time, and they're like, well, could you just like screen cap it? And I was like, ugh. I didn't know what I was doing. I had never really done YouTube before. So I grabbed one of these little lapel, I didn't even have a lapel mic. I was just like, I hit record on my laptop, and I was like wandering around the room so the audio like comes and goes. It was so bad that I needed to post it, and I didn't know how to post it on Canvas. So I figured I'd just put it on YouTube, and I was this like one click away from doing unlisted. But at the last minute, this is back in 2016, I was like, yeah, what the heck, I'll just post it. Thinking nobody's gonna watch it anyway. So I had 0 subscribers right back then. And so I posted it, and to my surprise, people like are watching it. It's not my students, because it's like growing and growing and growing. And people were saying like, hey, where's the rest of the videos in this series? Because I'd only recorded like a month out of the whole semester. Yeah. And it inspired me to be like, dude, there's an audience for this. And I had no idea. Yeah. So I started getting serious about it. I slowly leveled up my game. I started getting lapel mics. During COVID is really when I made a big improvement on that. I went from recording whole 50-minute lectures, which is what I teach in my class, breaking that into 5 to 10-minute videos on specific subjects, which is really what YouTube is. That's better, what you want for YouTube. And the quality, the demos, everything just got better, and the numbers have just taken off. We're at 40,000 plus subscribers now, over 5 million downloads, I think. It's wild how the way I see it is this. I grew up reading Callister's textbook. It's the reason I study material science. I read that and I was like, dude, this is it. And I think the textbook medium has largely died in the year 2025. It's a bit sad because I love textbooks, but that's not how students learn nowadays. They hop on YouTube, and increasingly they use Gen AI. And so the way that they learn is changing, and I happen to be at the right place at the right time to create what I feel is the material science textbook of the future. It is my playlist. My intro to MSE Materials 101 has gone nuts. Elon Musk 5 years ago or so tweeted out, take Material Science 101, it'll change your life. And I had named my series that, and I saw the spike just go nuts as people discovered this and realized this discipline that they didn't even know existed, and how cool it is for tech nerds like our audience tends to be.
So you have been doing your YouTube videos for a long time. You've been doing materialism for a long time.
Yeah.
But materialism
between both of them?
Doesn't have any video content.
Yeah.
Why did you decide to just leave that, since you clearly know how to do the video as well, which is another whole skill set of learning how to edit video? So are you ever going to make
For
video
materialism,
versions?
we've done 1 or 2 episodes, like 2 maybe, where we did video. It's mostly an effort thing. In the early days, we were unpaid, right? Nobody sponsored our show in the early days. It was a lot of work, and adding video was like adding more work to what was already like a pro bono like side gig. We're big enough now that I think video would actually make sense. I do a lot of other videos still, right? So for example, I do a lot of educational video content. So I don't know, it's a conversation to have with my co-host again, because we cross-post to YouTube, but it's just a static image right now.
Right.
Having that be replaced with an image would be more editing for sure, but I think it would probably be worthwhile. Some people, when we do interviews, they prefer not to have video as well. I think that it's easier to have just a conversation and it's just their voice.
Right.
Personally, sometimes when you're listening, especially if you have 2 guests, which is, as I don't like to have more than 1 if I can help it, because 4 voices, it's hard to know who's speaking. Your brain
That's right.
it's a challenge. With video, really clears that up.
Right.
So it's something I would definitely consider. I have considered. It's likely in the future for us, but we haven't taken the plunge to do video yet.
And of course, you have to have video to catch the expression on someone's face
Absolutely.
when they eat hot sauce.
Yeah, so this is something I do, right? So I was inspired by Hot Ones. I do this material science hot takes. I ask a bunch of material science questions while eating these just stupid hot sauces. And it's so fun because I'll ask them like a question and they're just like, give me a minute. It's really great. The last guy was crying. I've actually interviewed 3 department chairs in a row and it's been really fun. So yeah, I think that it's probably the future of where we're headed.
Well, speaking of the future, we've floated the word textbook more than once already.
Yeah.
And certainly there's so much utility for multimedia communication of any discipline, but certainly MSc in particular, that a static paper textbook just really is not as valuable in a lot of ways. And it still has its niche. There is certainly value in saying, here is a huge lump of all the information I'm ever going to need about a particular topic as a reference, but usually not as a teaching tool anymore.
I agree.
So where do we, as a community, where do we go in the future to not only communicate with our students better, but to educate the educators and to help us, the teachers, develop the skill sets that we need to move beyond the textbook and produce content that will be more valuable to our students?
So, like I said, I love Bill's textbook. Bill Callister, William D. Callister, is easily the most popular material science textbook author. He's my neighbor. He lives just down the road
By the
from
way,
me.
Bill corrected me last summer. His name's not Callister. It's Collister.
Is it Callister?
That's what he told me. I know. He told us all. It's Collister.
Well, I'm sorry, Bill Callister.
You were there when he said that, right?
It's on the record now.
Now I know. He's great. I've had lunches and I've chatted with him about this because I view like his book as this important thing, but you're raising an important point that like we still need resources like that where the full explicit details get laid out and is more easily searchable than video, although that's changing. We're building tools that make it easy to search through video and other formats. What I think is going to be the tool going forward is mixed media, right? Take materials informatics. We have released my entire course, which I'm teaching other teachers right now because it was the first course that came out on this. I release YouTube videos, which have the transcripts. I have my course notes, PDF slides or PowerPoints. I have Jupyter notebooks where we work through the actual examples. All of these things get released and they're all archived and they're all version controlled. And I'm updating those in real time. Try that with the textbook. You have to buy the 9th and the 10th and whatever edition. Mine, every time I teach the class, it's updated. So it's constantly up to date. I just heard a talk on microstructure featurization, that a technique I didn't know about, and I'm already thinking where I'm going to insert that into my microstructure featurization slides when I talk about, featurization tools. So I think that that's sort of the future. It's easy to share. In fact, we can co-collaborate, co-create these things. It's easy to add a GitHub repository, co-author. I've done that on a number of my courses. So I see it as a paradigm shift. The old model was slower, less, agile to make changes. It was good, but it was semi-static and it was hard to update it in real time. And I see the future as being much more dynamic, real-time feedback and changing these things.
And of course, generative AI is scouring all of your sites.
That's right.
So you can just ask it to write a code for you.
Yeah.
And as long as you know how to vet it properly
That's right.
and how to test it, you don't even have to learn you have to learn how to read code.
Yeah.
And
Not
you have
right
to understand
anymore.
what you have to understand how to
Even
test
if you
it.
don't know how to read it, you ask ChatGPT to explain it to you.
That's right.
Really. So I used to teach a Python coding course. It's funny. The guy who took no coding courses in my life was teaching Python. And in the past, pre-Gen AI models, I would spend 15 weeks teaching students how to do syntax. And at the end of the 15 weeks, a handful, maybe 10%, maybe 20% of my students, 1 in 5, could take an assignment that would be a modestly complicated code script and make it happen with the tools they learned. Now, I can, on day 1, open up ChatGPT or Cursor, whatever you want to use for this, and I can speak to my computer. I could upload the assignment and just say, here's the assignment. I could speak to it, I could describe it, and instantly, on the first shot, it usually gets it right. And if not the first shot, with maybe 1 round of iteration, I don't have to download a VS Code environment anymore. I can just throw it right into Google Colab. I mean, the game's changed. What used to take me 15 weeks to produce students who had the skill to do a thing, they can do it by just asking for it on day one, such that when I teach that course now, we can do 1,000 examples of building code together. In other words, they hit the industry like light years ahead of where they were before in the past. It's an absolute game changer for coding.
Mm-hmm. And one of the skills that we're really discovering that we need to teach even more now than ever is the being critical of the information handed to you. Because, generative AI is usually mostly right about
getting
most
better all the time.
factual topics and
it's
improving constantly, especially in the numerical
but
domain.
But it will still make mistakes.
Yeah,
and it's fascinating how they've gotten better at numerical. It just runs a Python script in the background.
But then for our students to have the self-awareness to say, I didn't understand this fully. How can I dig deeper? That's where I find myself really having to push them now, is to be critical of their own learning. And that's hard.
One way I've tried to make that happen in my course, I teach this big intro to material science course. It's a lab course and a lecture course. During the labs, all my peers were like, oh my gosh, you're going to have students just submitting Gen AI lab reports. And I knew it was going to happen, but I was like, who cares? Like, I use Gen AI to write everything from my grant proposals to my papers to my emails, like you name it. I use it all the time. Why am I going to say the students can't do it? That's silly. So instead, what I did is I decided for 10 of the labs, right? I had 10 labs. For 3 of those, I required that they used Gen AI to write the lab report. And you know what I did? I didn't even look at the final report. That's not what they turned in. What they had to turn in was, what was their prompt? What was the output? How did they fact check it? What was their process for introducing citations? How did they revise it? They had to show, in other words, instead of seeing the sausage, I wanted to see how the sausage was made. That is what they turned in, with the expectation that you have to use Gen AI, because when you get to industry, they will expect you to use this tool. And I view it as my role as an educator, not to worry about this arms race between Gen AI to cheat and Gen AI to catch cheaters. And that's such a zero-sum approach and a waste of time. Instead, I said, this tool exists. It is so powerful. You have to learn to use it, and you have to learn to use it correctly. Part of that means policing it, being skeptical of it. And part of it means just using it in its most optimal function. So prompt engineering and understanding the best way to get the results you're looking for. That's something I'm going to lean into even further next time I teach that. It might be 100% of my labs where they turn that in, because I care less and less about the final product. I know it can deliver a good final product. I want them to show me that they can get there and how they did it.
So you also want to teach them to be open to the unexpected. Because, we know as scientists and researchers that it's our failures that lead to all of our discoveries. And, there's a lot of things that, just like the question I asked you after your talk, it's great collecting all that data, but what if the data is wrong? And the data is always wrong.
There's always incorrect data.
And, students will always, come into your graduate students will come in and with their faces drawn, oh, the experiment didn't work. And they think it's this horrible thing, but you're like, oh my God, that's awesome. That means we missed something of the physics. And you can do that with ChatGPT if you're just aware that it can happen. So I wonder if we couldn't even create some contrived exercises that it's going to get wrong, that maybe you can help them discover something new.
I haven't done that. That's a really good idea with the labs, intentionally give them poisoned data that would be completely unphysical, and then see if the Gen AI is capturing that, and then have it be a teachable moment. Did you just take that? Did you just swallow that hook? Or were you skeptical a little bit? Are you just, that's a really good idea, actually.
I have to tell this story for a moment, but it's funny, first, what you were saying about how your first episode was in some ways the most popular, because it's like the first album from your favorite band.
Sure.
They didn't know what they were doing yet, but they just had all of the spirit to it.
That's right.
And it was so clear that they were so creative and just their whole heart went into it, even though it was a bad album objectively. So, having lived that.
Well, we will re-record our Steel Redux. It's coming. We're gonna redo it. We'll leave the original up, but we're gonna redo it.
Yeah. But as far as how that relates to the current topic, I was having conversation with GPT in front of my students in my Physics of Materials course. And of course, the theme was to be skeptical. And so I was asking it some questions, and it was giving some pretty solid answers. And then I asked it, who played bass on Michael Jackson's Man in the Mirror?
Okay.
And so it gave me a very nice answer. It was like, oh, so-and-so played this on this song and recorded, volunteers the extra information. Oh, they recorded with this artist. And so I turn to the class and I'm like, guys, why is this answer wrong? Of course, none of them know, but I'm like, nobody played bass on that song. It was all keyboards. But the point of that story is that if you give it a logically fallacious prompt, it will usually still bite and try to give you the answer it thinks you want to get. And so I really feel that in the experimental space, this could be a very productive angle to go of let's give it poison data and see if we can find where it commits fallacies in that analysis.
I just gave a talk here at TMS where I got a question about that. She essentially was asking, it was Rika Kobayashi, phenomenal scientist. She asked, what happens if you get the prompt wrong? If you don't ask the question the right way, in fact, you could adversarially try and ask a prompt that misleads it, and you can actually assess how well. What our tool was doing was extracting materials data from literature. And if you ask it to do something, it depends on how you ask the question. I've always thought about how to optimize that process. And it was a really interesting, thought-provoking thing that she asked, like, no, don't just optimize it. How could you make sure that it's being adversarially trained away from these malicious ways of asking it that will intentionally cause it to give you the wrong answer? Worth giving it some thought.
That's great. I'm looking at my watch, and I know we said we were only going to keep you here till 4:30. So
I got a student's talk to get to.
Yeah, so I think we need to end this. So thank you so much for being on our podcast, and I hope we can keep talking about all this because it's just fascinating. So thank you very much.
Yep, it's been a pleasure. And to the audience out there, of course, we'll see you on the next episode of Undercooled.
Okay, see y'all.